Hi, everyone. My name is Senicheva. I am a machine learning product manager here at Toloka. And today I will give you an introductory lecture on data labeling, where we will talk about crowdsourcing in general, who needs it, and why. In the following lectures, you will dwell on details and cover some aspects of the crowdsourcing more deeply. Our agenda for today is quite simple. We will cover 4 questions starting with why do we need data collection and data labeling? We will use our own data set or take a ready one from Kaggle, for example. What influences the need for data and data labeling in a company, and who collects data and who labels it? I'd like to start our lecture with a talk on why somebody needs to collect and label data. Nowadays, almost every large service and technological domain requires a supply of labeled data, starting from any search service, ending with health applications somebody might use on their phones. But first, let's plunge into history a little. So traditionally, people would say that there are 4 great leaps in the modern AI, which we may call the 3 pillars. Namely, they are algorithms, hardware, and data. Algorithms and modern methods for the AI made it possible to train very deep neural networks without the following dying out of a gradient. With the hardware, we managed to increase the computing power. So with the modern GPUs, we have ways to speed inference and prediction. And data production, and in particular data labeling, provides us with instruments to establish processes for statistical hypothesis checks. So nowadays, we want to have more complicated analysis than ever. For example, previously we were interested in a weather forecast for today or tomorrow, but nowadays we want to know the exact time when it's going to rain or snow. For the pillars, several frameworks were designed. For example, TensorFlow, PyTorch, and CutBoost are the frameworks for the algorithms. Many companies like Amazon Web Services started to provide different cloud solutions for the hardware, but for the data, there is yet no unified methods or unified rules for data transformation. So we might think about algorithms and hardware as of our familiar focus, but the data becomes our potential for growth. With data accessibility, the story is yet not so simple as we have seen. And although the data-centric approach has been widely popularized by Andrew Ng, it still feels like the dark side of the moon. Let's have a look at the other trends which re-influence the importance of data and data labeling for the future of AI. One of these long-term trends is automation. With new machine learning methods and models, we are able to solve more complicated tasks. Interaction between people and automation is promoted with the help of modern frameworks. So we have a human AI collaboration which contributes to the automation process. And thanks to the automation, we have more routine tasks and our mundane activities being automated, which helps us to have more spare time. So it is impossible to think about the future of automation without a qualitative data provided. And with more spare time, we will be able to focus more on better usage of data. So it is our assumption that if a humanity has more spare time, people will be interested in focusing on better data usage. So what do data scientists spend their time on? Because obviously these are the people who are dealing with data in any company. So you might think that data scientists spend their time writing algorithms and spend time on the improvement of this algorithm. So well, they are doing something funny, as you can see in this picture 1 and picture 2 subsequently. But it turns out that actually data scientists spend most of their time poking around on data. So 60% of a data scientist's time is spent on cleaning, labeling, and organizing data. So if data labeling takes so much time, maybe it would have been easier to take a pre-made data set and use it for our business purposes. Well, of course, you might do something like that. But unfortunately, off-the-shelf data sets rarely prove useful outside competitions. So if at a Kaggle competition, a model contest within the scope of a given dataset is expected, in reality, the whole pipelines of machine learning and labeling compete. So in the real world, those who have the tools to collect and label qualitative data win. And we will see this statement being proved by the following two examples, one of which will be emphasizing the importance of the machine learning production line. And the second one will be the notorious COVID, where we will see how poor data labeling did not result in a valuable machine learning method which could help doctors. Let's imagine that we want to teach a personal assistant. So people in the internet are toxic, as we can see from the corpus of data from Reddit or Twitter, for example. The first launches of voice assistants showed that chatbots are very fast to spiral into racism without proper text filtration. So that's why translation from toxic into neutrally accepted is important. So for such a task, a multi-step pipeline is required. So a company with a better data focus and better pipeline wins. So as we can see in this picture, this is really a multi-step process with loads of validations in between and lots of data activities. Another example would be the COVID test. So the machine learning community could have demonstrated the technology's potential by helping doctors diagnose COVID faster. And at an X-ray shot here on slide, you can see the result of one of the models which was about to be implemented into production. But everything is not so simple. And that didn't happen. So the machine learning community did not stay away and started working on instruments to help doctors. And although there has been already a great data collected from China, the pandemic started 4 months earlier, it didn't help much. So what was the problem? Well, the machine learning community has suggested too many models. And although the data from China and open sources have already existed, the data sets were of extremely poor quality. So the quality of data in its labeling have fallen short. Some of the examples, well, some shots, the X-ray shots, were made in lying position, and others were made while a patient was being seated. So in the end, the model has learned to distinguish the body position, and based on this, to render a verdict. So some data analysts did not pay attention to writings on the edges of the X-ray shots, where doctors could have written the diagnosis. Others used children's shots, and once again, the model has been learning for an improper target. So also there has been a lot of unclear data sources, lots of duplicates, and other data-related problems. So as a result, non-performing and even dangerous tools have been developed. So there are two obvious ways to improve product quality. The first one is working with the data, so to have more qualitative data of a better labeling quality. The second one is being able to validate and implement new models faster. So as you have seen from the past two examples, it is extremely important to collect more data, but what is more important and crucial is to have a high quality labeling and a fast integration of data into production. So there is a need to check the hypothesis fast, and to do that, online and offline valuations are required. So in the COVID case, there was a train set, but without the possibility of proper evaluation in production, there was no flow against which it was possible to calculate the model, and no way to calibrate the model as well. So big businesses have been solving this issue in the following way. There are both online and online valuations, but these valuations to work, we still need the understanding of how to apply data collection and labeling methodology. So let's have a look at an example of one of our clients, a search portal. So this was their approach to data evaluation. So they had both offline and online evaluation steps for every model they wanted to put in the production. And with such an approach, you decrease business risks for your machine learning solutions. So when do companies need data? We believe that there are 4 stages of data labeling maturity, and based on this maturity, a company's demand for data changes. So the first one is when a business is small scale and there is almost no demand for data. The second one is when you have a little or rare usage of machine learning methods in your company. The third one is when machine learning becomes an important part of your production and of your product. And the fourth step, the fourth level of data maturity is when data labeling becomes an important part of your machine learning processes. So data maturity level 1 is when labeling occurs occasionally, it is used for small tasks, and there is almost no need for some complicated models. You just use some rules and regular expressions, and probably an Excel sheet will be just fine for all your data demands. What could be an example of a company here? Well, you might be a small shoe store with maybe 10 sales per week. So at such a rate, one person can have a look at all the data manually. And of course, at such a rate, there is no infrastructure and no plans for labeling in your company whatsoever. At data maturity level 2, you might need something more complicated than an Excel sheet. So probably you perform some tasks using machine learning methods, but these methods are quite simple. And probably you might have some Python notebook, somebody in the cloud, where you store just one machine learning algorithm, which you're going to use once and forever. So what could be the example here? Well, just a restaurant wants to decide what comment to leave on their platform with some very simple rules. So what could be other examples is some simple user content moderation. Also, the example of a data maturity level 2 company is just wanting to remove some duplicates values from your product cards. So data maturity level 3 is when data labeling becomes a part of the production cycle in machine learning. So at this level, a company needs both quality and high scalability of the machine learning infrastructure. So there is too much data and a production cycle is required, and the understanding of data labeling methodology emerges. What could be the examples here? Well, to improve speech recognition in Alice, the voice assistant, a constant flow of audio and transcriptions is required. So freshly labeled data is used for model retrain in production in real time. Now, I would also like us to quickly touch upon the question of methodology. So for instance, here you can see different variations of labeling, which label the same fox, but labels it differently. So when you require a big amount of labeling data and there is no possibility for checking and evaluating separate labeling cases manually, it is very important to give clear interpretable instructions in crowdsourcing. So workers can understand differently what is required from them. And believe it or not, extremely diligently, they can do not what you have asked from them. So for object recognition, a simple path of images is not enough. And although the variation of cases that you see on pictures can be used for some purposes, but if you want a proper image recognition model, data consistency is required for it to work. So a data maturity level 4 is like the state-of-the-art machine learning infrastructure, which ensures a competitive advantage. To give you an example of a data maturity level 4, I'd like to give you a story of a self-driving car and snow. So the story happened in 2017 when a public demonstration had been planned for October. However, a few days before that, snow fell unexpectedly, even for Russia. The technology had already been trained using summer pictures, but because the data conveyor has been established and tuned, it was ready for launch and scaling at any moment. So in a couple of days, new data was gathered and the model was retrained, and the demonstration proved to be successful. So labeled data and algorithms should live in production in real life. Otherwise, your production is basically non-existent. The example here would be the story of self-driving cars in general, because for self-driving, not only data, but the labeling itself is crucial. So as you can see here on slides, in real time, a self-driving car model has to create multi-layer LiDAR with 3D cuboid map. So this is a very complicated labeling task performing real time. So what other factors can influence the demand for data, except for data maturity? Well, the first one is model restart frequency, is how often do we need to restart and reevaluate the model? The model ceiling, like the model reaches the ceiling of its performance, we need to create a new data, we need to create a new model, and probably we might need new data. And the third one is changes in our real world. So while talking about the changes in the real world, we touch upon the issue of data shift. So a data shift comprises three biases that occur in our data. The first one is when the input set changes with time. An example here would be the language any of us speaks. So a language changes with time, although the target distribution of classes stays the same. The second one is the shift of the target variable, which is the distribution of classes. So the recent example of the second data shift can be the Dune. Well, previously, probably if you typed Dune in any search engine, you received these beautiful images of the ridges of sand. But now, if you type Dune, you probably would have the posters from the recent film. So the third type of data shift is change of the environment or of a data domain. It's like trying to apply an old algorithm to a new task. So an example of data shift here, as we have already talked about the language, would be the example of machine translation from any translator is trained using literally and bureaucratic language. So they use, for translator training, scientists use legal documents, classic literature, Wikipedia articles. So a translator frequently encounters unusual language usage, including slang, obscenities, and poor grammar. But for a high quality machine translation, it is required that the model is tolerant to mistakes, and against all odds, it is able to provide us with a high quality translation, even if you need to translate a phrase from a recent meme. So who is responsible for labeling data in a team? Well, there are several approaches. The first one is labeling within the company, where labeling happens thanks to the efforts of a data labeling engineer. You can also outsource these activities to freelancers and vendors. You can use crowdsourcing, and you can use synthetic labeling. So all these approaches have different pros and cons, which we will cover in the following slides. So the first approach is trying to label everything within your company. So what are the benefits? You have predictable results. You probably have high accuracy because you have direct interaction with those who are responsible for this labeling. But the cons are time-consuming and poor scalability. Well, probably for the majority of the companies, this is how they come to the idea of the inner crowd emerging in their company. The second approach would be to use outsourcing. So it's when you are hiring temporary staff or freelancers, or you just might order labeling from an external team. So what are the benefits? It does not distract data scientists from their tasks, and they can be focusing and tuning and creating algorithms. It is easy to plan your resources. But from the drawbacks, you have less impact on quality, and it can be very expensive and very slow. So it takes longer, believe me, but try it. It is also possible to label your data using some rules. As a result, you will have synthetically labeled data. So the benefits are you have fewer usage restrictions. It's very cost efficient and very time efficient. But often, unfortunately, it ends up even worse than the real data. Another approach to get your data labeled would be to use crowdsourcing. It sounds like a miraculous instrument because it allows you to be fast, scalable, it is customizable for any task you have, and also because there is a way to create a free market, it is cost effective. Unfortunately, one must know how to extract the benefits of the crowdsourcing. That's why we have Toloka. And also, for all these benefits to work out, you have to invest in the quality control tools that you use while labeling your projects. So historically, if you have a look at Toloka, at first, it was designed to provide data for search portals for them to have enough labeled data for machine learning. Then Toloka has grown into infrastructure for all Yandex products and services. And nowadays, we provide data labeling infrastructure for the external clients as well, because we see the demand for scalable and efficient data labeling. So as a conclusion, what did we manage to cover today? First of all, we had a look at the appearing data trends. Secondly, we have examined why off-the-shelf data sets won't solve real-world problems. Also, we saw that there is an increasing demand for unconventional labeling in the world. And we have also researched several approaches and methods to how to get your data labeled. So that's it for today. You will also receive a link to our Slack community where you can post all the questions you have regarding this course and this lecture in particular. And some of our Toloka's employees will answer you in a short period of time. That's it.